Right, number 11. We've got to solve. So we've got fractions. So we need to cross multiplying to get it all on one level. So we've got 4 times 2y plus 1, 3y minus 2. Right, expand the brackets. Gives us that. So now let's take away the 3y. I'm going to take away the 4 as well. Do it in one step. So I've got 5y equals minus 10. So y must be minus 2, negative 2. Quite easy 4 marks, that one. Right, number 12. On the grid, draw a line 4x plus 3y equals 12. Right. So what I'm going to do, I'm going to use the cover up method. So if x is 0, I cover up that because 4 times 0 is 0. So 3y equals 12, so y must be 4. Now I'm going to do the other way round. So I'm going to make y 0. So 3 times that can go. And this time 4x equals 12. So actually x is 3. Okay, you can use that method when the equations are in that form. So 0, 4. 0, 4 and 3, 0. So actually the line is going to go down like that. See if I can actually draw it in the right place with a ruler. Okay, let's label it 4x plus 3. Oops. I knew that was going to happen. Sorry, that's the ruler. There must be a better solution to that. Oh, we've done that already. Right, so we've got 4x plus 3y equals 12. Now, show by shading the grid the region defined by all 4 inequalities. Right, so we need 4x plus 3y is less than 12. Well, it's going to be that side of the line because I can put 0, 0 in. 0 plus 0 is less than 12 using that point. Now this line here, this must be y is less than 2x. So let's pick a point. This side of the line, if I put 6 in, 2 times 6 is bigger than 0. So actually we need that side of the line. So I've dealt with that one, dealt with that one. Now I need y is bigger than minus 3. Well, minus 3 is there. So basically anything above that line, y is greater than minus 3. And notice they're all solid lines as well, they've got the lines underneath. And then x is less than or equal to 4, which is that line there. And I need that side of the line. So it is above that, right, it's this bit here, but not that little triangle. Okay, so we've plotted those lines on, worked out what side of the lines we wanted. That's the bit we're working with. That was number 12. Number 13, bit of rearranging by the looks of it. Given that c is positive, make c the subject of, right, so we need to rearrange this. Well, let's get rid of the square root to start with. So square it. Now I'm going to take or add this to both sides and take away the a squared. So I know b squared equals c squared equals 1 minus a squared. So rearranging it, let's get c squared over here. So I've got b squared divided by 1 minus a squared. So actually c is equal to the square root of b squared 1 minus a squared. So quite a few steps there, making it positive, rearranging it, dividing by 1 minus a squared, timesing by c squared, and we get our final solution. Right, next question. Alison is using the quadratic formula. She substitutes values into the formula and correctly gets... Right, so that's actually her workings, isn't it? Work out the quadratic equation. Right, so we just need to work out what A, B and C is. Well, A is easy because the bottom of the quadratic formula is 2A, so A must be 2. B, well, it's B, oh, there you go, B. It's minus B plus or minus, so B is 7. Now C is from this bit here, but this bit here is made up of 4 times A times C, which is equal to 32, and actually A is 2, so 2, that's 8, so C must also be 4, because 4 times 2 is 8, 8 times 4 is 32. It's minus 4AC in the formula, so the C must be a positive 4. Okay, give your answer. So let's just write it out how they want it. 2x squared plus 7x plus 4 is equal to 0. So it's all kind of using the quadratic formula, but in reverse. Right. Next question. Here's a speed graph for a car. Work out an estimate for the distance the car travelled in 6 seconds. So the distance covered is basically the area under the graph. And what I'm going to do, I'm going to use the, I'm going to divide it into different shapes. So I'm actually going to do a triangle. I could use the trapezium rule actually, but I'm going to use a triangle and then add the 2 areas of the trapeziums together. So to start with, I've got a triangle that's 2 wide, 2 high, so it's basically 2 times 2 divided by 2, plus, now the area of a trapezium is half A plus B times the height. So A is going to be 2, B is going to be 5, so they're the 2 parallel sides added together. So I've got 2 plus 5 divided by 2 times by how wide it is, and then the final one I've got 5 plus 8 divided by 2 times by 2. Put that all into the calculator, I get 22 miles. Okay, there is a mistake on the mark scheme. I think the mark scheme says 26 because they misread one of these, but it is 22. Okay, so let's have, I think there's more questions on this one. Is your answer an underestimation or an overestimation? Well, it's going to be under because all of my... Oh no, it's going to be over, isn't it? Because these are going over the line. So it's an overestimation because my shapes are slightly above the line. Okay. Now, calculate an estimate for the gradient of the graph when t equals 8. So what we need to do is need to go to t equals 8, draw a tangent, and then work out the gradient of the tangent. So tangent 8, it might all go wrong again because I'm using a ruler. Try and work to an exact value. Oh, managed it. Okay, so we need to work out from there to there. Well, that's easy, that's 4. And then we're at, what's that, 5, that's probably 7.5. And then that is going to be 21, 22. So the difference of 22 and 7.5. So 22 minus 7.5 divided by 4. So you would tap that into your calculator. You're probably going to get different values here. That's actually going to give us 14.5 over 4, which gives us 3.625. Now, looking at the mark scheme, anything between 3.4 and 3.9 is fine. It's very hard with those tangents to get them spot on. Describe fully what your answer in part C represents. Well, the gradient is the acceleration of the car, and it's in meters per second squared. And that's the distance time graph. Right, question 16. 15 boys and 9 girls in a mixed hockey team. One of the boys and one of the girls are going to be chosen to collect the cup. Work out the number of different pairs that can be chosen. Right, so for every one boy, there are 9 different girls that could be picked. So actually, we can do 15 boys times 9 gives us 135 combinations. Okay, 2 of the boys are going to be chosen to play in all boys teams. Sam thinks the number of different pairs that can be chosen is 210. Tom thinks the number of different pairs. Right, okay, so we've just got 15 boys, all boys team, and we are, how many different, we've got 2 boys. So the choice, picking the first boy, we've got 15 to pick from. Picking the second boy, we've got 14 to pick from, which is actually going to be the 210, but we need to half that, because if that's giving us, if we had boy A and boy B, if we just did 15 times 14, it would also give us boy B and boy A, which is obviously exactly the same. So we need to divide it by 2. So actually, Tom is right with 105. And that's because of that reason you need to half it. Now, question 17. We've got ratio. A to B is 5 to 8, B to C is 6 to 25. We want A to B to C. Right, so 5 to 8 is A to B. B to C is 6 to 25. Now we want these numbers the same, so then we can put them all together. So the obvious number is 48, because we can times this one by 6, still in the same ratio. We can times this one by 8, still in the same ratio. And now we can combine them, A, B, C. Now this was actually an exam question not that long ago. And all we now need to do is simplify it. Well, they certainly can be divided by 2. But now they can't be simplified anymore, because 3 and 5, 3 does go into that, 3 doesn't go into 100, 5 doesn't go into 24. So actually A to B to C, that's in its simplest form.